All right, good morning from Tews. You guys are doing great, right? Any problem? None. I know. Okay, so today we'll look at combining colors. But I do know that just a few days ago we were looking at filtering colors, how you can filter colors. So we looked at this part. So today we'll proceed to look at combining colors. Okay, all right. So let's move on. Alright, so these guys are saying when different colored lights are combined, it is found that all the colors can be made from different combinations of just three colors. Alright, I know this is a quick statement and one that's very deep and one that needs a lot of consideration. What the thing is that we see a lot of colors, okay? For example, maybe your parents' car is the color of your parents' car is maybe, let's say, black, or maybe it's a metallic green, or maybe it's let's say blue. All right, that's the color of your parents' car. Now, you do know that you can also make light have a color, like we saw last time. That light also can have a particular color. And by the way, for the sake of posterity, apparently light with only one color is known as monochromatic light. Okay, so it's monochromatic light. Now, you've seen it before that you can produce yellow light, blue light, whatever it is. Okay, you can do that. You can take white light and put a filter and it'll give the color that you want. But did you know that when two differently colored light rays meet, they produce a new color? Did you know that? Did you know that when, for example, blue and green meet, they produce another color? Did you know that? All right, you should know that today. And these guys are saying that all the colors of light that you see, all right, so all the colors that you see of lights today can be made just by the combination of only three colors. So you can choose the amount of percentage to add to the color. Okay, to add this amount of blue, this amount of that, this amount of that. Now, they're moving on to say they are red, green, and blue. So they're saying that you can make all the colors in the world. Okay, you can make all the colors in the world just by combining three colors. And these three colors are called primary colors. And these primary colors are red, green, and blue. So red, green, and blue. Meaning to say you can make any color of light just by combining these three. So let's see some examples. For example, in this diagram, you have this Venn diagram. For example, when blue light, this is blue. When blue combines with red, the color that you produce is known as magenta, or you can call it magenta, or I just prefer to call it magenta. Okay, so that's the color you produce when you combine blue and red. Now, when you combine blue and green, the color that you produce is called cyan. All right, cyan. I don't know what you call it, cyan, but it's cyan, or shen. When you combine green and red, the color that you produce is yellow. So you produce yellow, as you can see there. And surprisingly, when you combine the three colors all at once, the color that you produce is called white. It's nice. So the white color that you see, the white light can be produced from these three. So if you have a bulb which has a blue color, another bulb which has a green color, another bulb which has a red color, they can produce white light. Alright, so let's see some examples right here. Question 8, it says, the colors on a television or computer screen are made by three different colors of substances called phosphors. So if you have a TV at home or a computer monitor, All right. So those colors that you see, if you see a person, whatever it is, it's built from different colors. So those colors, they say, are made from only from three different colors of substances called phosphorus. So they're saying they glow to release their color of light. Now, what do you think the colors of the phosphorus are? All right. So you do know that a TV is supposed to show all the colors. If there's a black car moving in the TV, it's supposed to show. If there's a black man in the movie, he's supposed to show that he's a black man. If there is a dark-skinned person, he's supposed to show that he's a dark-skinned person. If he's a light-skinned person, he's supposed to show all that. So all the colors are supposed to be shown. All right. So for you to achieve that, you need colors which can make all the colors in the world. And to answer that question, what do you think the colors of the phosphorus are? I think the colors should be blue, green, and red. Okay, blue, green, and red here, because these are the primary colors: red, green, and blue. And explain your answer, because these colors are the only ones which can make all the colors in the world. So that's why I think they should be there. So it's red, blue, and green. There's a song by Culture Club. So Culture Club is the band. They did a song called Karma Chameleon. Listen to it. There's a part they say red, gold, and green, red, gold, and green, red, gold, and green. Question 9, it says, which primary colors overlap to produce yellow, magenta, cyan, and white light? So I'll leave this to you guys to as a homework. So when you're done, write it in the space given below. Yellow, magenta, cyan, and white light. Which colors do you need to overlap to give you this? Okay. All right. So for discussion, identify the light source you are using for seeing things around you. So choose an object in the room. Describe the changes that take place in the light from when it leaves the source until it reaches your eyes from the object. Is it refracted through glass? Is it partially reflected from any surface? Which colors have been absorbed by the object? So this will be a perfect discussion. It will need about maybe 100 words. I'm not very sure, but yeah, not less than 100 words. So explain to say that, for example, like right here, I can explain a few things. I'm outside, so I can see the light from the sunlight. So the sunlight is hitting. So you have to choose any object. Okay, I think that was just say discrepancies. Yeah. So the object I'll choose. Oh, there's a car right there. It's a blue car. It is a blue car. So the light from the sun coming down with 7 colors of light rays hitting the object, and 6 colors are absorbed, but only 1 color is reflected back to my eye. To my eye, yes, exactly. And that's the blue color only, but the 6 colors are absorbed. You should do the same, please. So have a good day. See you in the next lesson on colors and paint. Yeah, it's all about painting now. It's art. Oh yeah. Can you paint some Mickey Mouse? Minnie Mouse.